Good morning, guys. Good morning, good morning, good morning. Seems like we have a limited number of participants today. Can you guys hear me?
We can.
Perfect, perfect. So we're just 11, which is highly unusual. I think the last class we had were like closer to 30. Right? Okay. So can somebody walk me through what you guys discussed yesterday with my colleague, Miss Nkechi Omolola? Who was the class yesterday? I heard you guys had a lot of questions for her.
So, yeah, good morning, James.
Good morning.
Yeah, so what we did yesterday was we tried to configure our Git. So once we did the configuration, she gave us those commands to do the configuration, and we check if it was properly configured. And she also showed some codes to, for example, if we need to like initialize a direction in our PC, and how to create a file, how to like commit it to the remote Git, and how to push stuff like that.
Okay. All right. Okay, that's good. That's good to hear. That is good to hear. And it sounds like you guys covered a lot. All right, so that means the assignment at the end of today's slide, you guys should be able to get that done, right?
We hope so, because.
And sorry, you can go ahead. Okay.
No, sorry.
Okay. All right, if you guys can just give me 1 minute, I need to sign in as the host of this course so I can take over and share my screen. I'll jump back in less than a minute. Okay. Okay, guys, I'm back. Apologies for that. All right. So how many? I was still 13. We'll have to work with the number of people we have on the call. All right. So you guys talked about Git and its Git commands, right? So we will be continuing from where we stopped in our session on Monday. So we'll round up on. So this is where we're working on. So we stopped at some features of Git. We stopped at features of Git. That's in the last session we had. And we talked about what the features being open source, scalable, distributed, security, speed, branching, and merging. And I know that by now you guys know what branching and what merging is. Right? You guys know what branching and merging is. Hello?
Yeah, we didn't cover that in class yesterday.
You guys didn't cover that in class yesterday. All right.
Yeah.
All right, so we'll be expanding on that. I think that will be our last. We'll expand more on that before the end of the week, right? So just to we'll expand more on that, before the end of the week, right? Okay, so then you guys talked about workflows in Git yesterday, right?
Yes.
Okay, cool. So I think in our last class we talked about open source, how Git is open source and how scalable it is, and what distributed means. Well, I think we talked about this too, but I will be covering from distributed, security, speed, branching, and the rest of it. Or better still, we'll just talk about the entire features of Git. How does that sound? So, excuse me. So yesterday, you guys talked about the workflows of Git, right? You talked about what the origin is. You guys talked about right?
Yes.
So you guys talked about different use cases, subteam fetches, and the rest of them. All right, let me not confuse you guys a little bit more. Let me not confuse you so much. I'll talk about the features of Git and kind of leave workflows behind for a bit. And when we are done with that, we'll do a bit of classwork in the afternoon session, right? So we'll be able to understand what this image is talking about then. Okay. So we'll start with open source. So Git is an open source tool. It is released under the GPL General Public License. What that means is it is publicly available to anyone to make use of. You can easily get access to the source code, right? So that you can make improvements on it if you so choose. Or you can also work in as part of the maintenance community that is maintaining Git by adding your contributing to the development and maintenance of the Git code, the Git source code, right? So that's generally what open source means, for Git to be open source. Now, when we say Git is scalable, right? Git is scalable, which means that the number of users that you can have on a single repository is not limited. It can grow to accommodate as many users as you'd like that's working on that same repository, right? So in that sense, if it's only you that's working on your repository on that project, it's Git will still perform optimally for you. If you're 200 people working on that same repository, Git will still perform optimally for you. The same experience, one person has the same experience 200 people will have using Git to work on a single repository. So it scales very well in terms of more number of users or what have you, right? Then distributed, right? Today's session is generally supposed to talk about the difference between the understanding what distributed version control systems are. Now, one of the best features of Git, in my opinion, is Git allows you, right? Git allows you to have different copies of your repository, right? You can have every clone. You can clone a repository, all of the branches attached to that repository, right? All of the changes on those branches that are in that repository, and have them cloned down to your local machine, right? You can have a distributed version control system in the sense that you have a clone of what is on the remote branch or your individual computer, like your local machine, wherever you are, right? God forbid something happens to that remote branch, you can always use that current version that you have on your machine to call back the code, right? Or something happens to your own branch or your local machine, you can always reclone that remote and have all the updated code that you have pushed and committed to Git, have them back as if nothing happened, right? You can also migrate from one machine, one device to another device with your code still intact as at the last commit that you had, right? Without having to start troubleshooting. And can you just give me 1 second? There's water wasting in where I am. Just 1 second, please. Check the water in the pump. All right, guys. Apologies for that. All right, so somebody is pumping water and it's wasting. All right. So we're going to explain the distributed as one of Git's great features is that Git is distributed. Distributed means that instead of switching the project from one, like I was talking about just now, switching the project from one machine to the other, you can just create a clone of the entire repository. That's like copying the entire repository from the remote branch with all of the branches attached to it, all of the commit messages, all of the changes that has ever been pushed to that branch. You can have it brought that to your local, to that device, right? Instead of having one centralized repository, you can send changes to every user that has their own repository that contains the entire commit. So when you are pushing a change to the remote branch, right? Sorry, to the remote or to origin, to the remote repository rather. That change that you have pushed, every user that has access to that repository can just do a git pull or a git fetch of that branch, and all those changes that has been merged into that remote branch can then be, everybody will have access to it. Even if you're pushing, let's assume that you guys don't know what branches are yet. So I don't know if this scenario would make sense. So just work with me, all right? Work with me and try to understand this. Imagine, right, you have your repository is a straight line. The repository is like a straight line, right? With different commit messages along the line, right? Different commits, and different commit, and different commit, right? Now, you are trying to build, let's say in the process of writing code, you've written a long span of code, you've added features and features and features on one long commitment, on one long thread of commits, right? Then that's on your main branch now, right? Now you have a bug that was introduced or something in the code that you wrote. There's a feature that you added that needs to be fixed, right? Instead of going to the main, it's advisable not to work on the main branch. That's the branch that has all of your code so that you don't spoil things. It will be easy for you to work back those changes and all, right? So in order to avoid working on the main branch, what you can do is you can branch out. Now remember, we have a straight line. Let me just use this line, this blue line here. Can you guys see my screen?
Yes.
All right.
Yes,
Now
I can.
imagine this blue line in the middle of here as your single your main branch. It has a single line with each blue dot as a commit, and with each commit it's moving and moving and it's still going straight, right? Ayo, your hand is raised. What's your question?
No, sorry, it was a mistake.
Okay. All right. So you have a thread of commits. Can you take your hand down, please? All right, cool. So you have a single thread of messages, of commits rather, right? That one straight line of commits. And somewhere along the line, you realize that a feature that you have worked on, either it needs an upgrade or it needs a fix for a bug in it. Not that it affects the rest of the code, but that maybe you want to make a change, slight change, or whatever. That's an scenario. You can create a branch for multiple different reasons, right? So that branch now that you have, that is on a straight, that main branch I have that's on a straight line, you then decide to branch out. That's create a whole new line for that fix, right? Which is where this guy comes in. Where is the best example for this? Where this line that is at the top, this one on top of it, that is a different branch. You branch out. Now you have a main branch. This is the main branch, and then this branch that you branched out of Git is, you can call it feature fix or the fixed branch. You name it, you have to give it a branch name. So you name that branch, let's say a fixed branch or feature fixed branch or whatever you want to name it, right? You give that branch a name and then you add the code. Now that branch you've created carries everything in that repository. It has everything that is in that repository as at the last commit before the branch was created. So it's like having a clone of that repository, but in a what's it, what I'm using. I'm trying to paint a picture that you guys can easily relate. So I believe in giving you guys something to imagine, then in order to be able to assist you understand the entire what it is, right? So imagine a branch as a mini clone of that repository, a clone within a clone, right? And that copy of that branch will be as up to date as the main branch as at the commit when the branch was created. So it's like, okay. Remember, I was talking about taking pictures, Git doing like a snapshot of the entire repository, right? Now, the branch will take a snapshot of the entire repo as at the last commit and go on a different route. Then any change you add to that branch that you just created will not be reflected in the main branch, right? So you branched out, you're on a different branch, although the branch is moving forward as well. You add a new commit, it goes one step forward. You add another commit, you can keep adding features and changes and on and on. But then eventually, those changes you have been adding, you need to now introduce it back to the main branch, right? That is where a merge has to be done. So you have a branch that was created off the main branch. You've added commit message, you added different changes and commits, and now you have to merge it back to the main branch. So that main branch will carry all of those fixes that you've introduced, all of those code that you've introduced back into the main branch without breaking anything. So that is where a merge comes in. So what a merge is it will pull that branch that you branched out, add the code back in, and include the commits in that branch into the commit history of the main branch. I don't know if that's clear to you guys.
Clear.
Is it clear?
Please come again. Please come again.
Okay. All right. So imagine you are an accountant, right? You're an accountant, you're keeping record of every trade that has occurred or every transaction that has taken place in your shop, right? Then as you're taking record of everything that is going on, you now have a little kiosk that is outside of the shop. Let's say the shop is here and you have a little kiosk that's just in front of the shop. Now that little kiosk rather has to take on transactions, is doing business on its own. So another accountant is there that's capturing all of that data, all the transactions and all, right? It's still trade for the entire business, yes?
Yes.
Good. So as you're moving on, you're making transactions which are likened to commits, new changes are taking place in the main branch, let's say the main business now. You're adding changes, you're committing messages, you're committing changes, and you might even be merging other branches, right? Other branches that are created. But that kiosk now, at the end of the day, after doing all the transactions for the day, you need to now merge that account of the kiosk and that of the main shop, right? That is
okay.
The branch that was created, that has added all these changes and all these commits, is now about to be merged back into the main branch, right? So what Git will do is, after it checks if there will be a merge conflict, if there is some sort of the commits, if in most cases is where a merge conflict occur is, let's say there is a line of code or a file, right, that had maybe two people working on it at the same time, or you worked on the same line of code, and you changed something that had already been changed. So yes, you work on the same piece of code at the same time. That's where you most times you create a merge conflict. Or if the commit is behind or more ahead than the main branch, right? We'll still get into commits, merge conflicts later. So let's just resolve this. So now you've created that branch, and now you've added those changes and you've added those new features or whatever it is that you've added. You now want to merge that branch back, that code back into the main, because your entire application will be running on the main branch, right? So
yeah,
when you bring that branch in, you create what is called a pull request. Most times we shorten it to PR. A pull request will take those changes from the branch that you created and then merge it into the main branch, the primary development branch. Do you understand? So that branch becomes the full it now has the full history. Now it will also carry the commits of that branch that you're merging and add it to its commits history. So you can see as at when this branch was created, this was the things that were occurred on this branch, and it was merged into this. Yes, I said for troubleshooting purposes or for record purposes, you can always refer back to this. Do you understand that now?
Yeah, I do understand.
All right, is there anybody that's still confused on it? Hello? Is there anyone that's still not clear?
We are clear.
All right, perfect. So we'll keep going then. All right, so now that is what, now we don't have a distributed system that can track all of these things, either from your local computer, from when you clone it, to any other, every other person's computer. You can easily, if the system is distributed, that information is readily available, right? You can always get access to the latest updated code as at when it's available, right? Then the security. Git is secure. It uses the SHA-1 security hash function to name, identify objects within its repository. Files and commits are checked, retrieved by its checksum at the time of checkout, stores it in history such the way that the ID of the particular commit depends upon the complete developer history leading up to that commit. Once it is published, one cannot make changes to the old version. What is said in essence is it uses this security hash function to hash commits. So it's easily readable, it's readable quickly, right? Using the IDs of the commits, right? And then you cannot change a commit. That's, you cannot change after it has been committed. That's, you cannot change what was committed. You can maybe change the commit message, right? But you cannot change the code that you have committed. I don't know if that makes sense.
No.
Okay.
Not at
Hey,
all,
we
not at
don't
all,
understand.
sir.
We don't
Sorry,
understand.
President, please come again.
Let me
Okay. Now
explain some.
imagine, okay, you know, like I said, Git takes snapshots of your code, right? All the changes, right? It shows you this is the line that changed, this is the line that changed, this is the line that didn't change, this was what it changed to, and all of that. But that happens after you have committed those changes. Meaning you can still go back and take those lines, but return those lines to their original state before you commit, right? But once you have committed that change to Git, you cannot go back to the code and start altering that commit to not show that this line was changed. If you go back after you have committed a message and return the line, revert those lines of code back, that's fine. Then when you commit, it will be a brand new commit. Do you understand? Let me maybe paint a clearer picture.
So
Imagine,
Okay.
okay, imagine as I am like this, I'm putting on this shirt, right? This is my initial state. So I want to commit, I want to make some changes. I remove this shirt and put on a different shirt, and then I go and commit. Git will take a picture of what I'm wearing, right? It doesn't mean that after I commit, I will go back. I can't go back and change this shirt, which I then will. After I've committed, the current version of that commit is that I was wearing this shirt. So I go back to Git wearing another. I go back to Git wearing another shirt, a white shirt, a completely white shirt, and I commit that one. Right now, remember, commits take timestamps and different things, right? And commit messages, and it has a commit ID, which is unique. So after I've committed the new white shirt, right? The first commit, let's call it commit ID 1. I cannot go back to the code or to that image of that the snapshot I was taking and change that in that shirt, in that code, that commit I was wearing this shirt, and change that shirt to white. You cannot alter it. You can still change your code and create a new commit, right? Which is okay, it's actually possible. But in the commit that you have committed, you can't go back to alter the code. I don't know whether that's clear.
Yeah.
Yeah, it is. Yeah, it is.
I think some people might still be confused. If you
I'm okay.
okay, if that explanation wasn't clear to you, please can you just maybe unmute yourself and speak up, please, so I can explain
Not clear to
some
me.
more. It's not clear to you? Hello?
It won't be bad if you can explain again, sir.
Okay, perfect, no problem. Okay, so I like to paint images that kind of explain what I'm saying better. All right. Imagine that you're a photographer, right? You're a photographer, and somebody comes into your shop with to have a photo shoot. They come with 3 outfits, right? You tell them to wear the first outfit. They wear the first outfit. They snap that picture. They've taken the first picture, right? That picture that they've taken, it's a physical picture. You can't alter it, right? It has, or if it's even a soft copy picture, it has a timestamp and a file name, right? So you can't, you can rename it, but you can't change the timestamp when that picture was taken, right? And then you cannot actually change the picture itself, the image that was taken. You can't change it, you can't alter it, right? So then you come back, you try out the second outfit, and then the process of taking the picture occurs again. And that picture is taken, it has a file name and a timestamp, right? You can change the file name, but you can't change the timestamp, right? That's a different outfit. So you go back and try out the first outfit again. And then the picture is taken again. You can still change the file name, but you still can't change the timestamp. What this security is saying is you cannot change the image. That's the code that was captured in that commit. Do you understand? Not that you cannot go back and change your code. Git keeps a record of your code. It keeps like a record of your code. Not that it will if you want to make changes to your code at any time, it will stop you. No. But as that when you commit a code, when you commit changes, that picture, that image that was taken then, that capture that was taken then is what Git keeps. So as it has taken that picture, you can't change that picture. You can't change the commit itself. You can't change the commit message that came with that picture. You cannot change the ID of that commit or the timestamp when that commit was done, but you can change the commit message, right? Let's say you had a typo or you didn't put a descriptive enough message. You can change that. But what was committed, like the image that was captured by Git as at that time, is you can't alter it again. But if you change your code, you can create a new commit. So that if you want to now go back to a different version of that code, you only have to take the commit ID and then go. Git will then show you exactly what your code was as at when you created this particular commit. Is that clear now?
Yes, sir.
Yeah.
Clear.
Yes.
Yes.
Yes. Very well.
All right, cool. So I'm happy everybody understands that now, right? So that is generally what Git does for you. So, so as for speed, Git is very fast. Oh, sorry. Git is very fast, so it can complete all tasks within tasks in a while. Most of the Git operations are done on local repository, so it provides a high speed. Yes, it is true, right? So when you're working, most times when you're working with Git, it's Git's remote repository or remote branch is just what it is. It's remote. But when you're working with Git, most of you're working with it locally. So when you're writing code, you could be writing code, adding new features to the branch. Like I explained about what a branch is. The main branch is sitting in Git, your remote repository in most cases, right? And you won't be working on your main branch, right? So that you do not damage your commit history. So you can easily trace back when you introduce a change or whatnot via creating a new branch and merging that branch to the main branch. You can always see when you introduce a bug or when you introduce a piece of code, or you can always refer back to different versions. Does that make sense, right? So when we talk about Git being having speed based because it's mostly done locally, is as we are talking like this now, I could be writing code And the Git version, Git that I'm using is the Git that is installed on my device, right? Git is capturing every change I'm introducing to my code, right? If I add a new line, it captures that I added a new line. The line of the which file added had that change, it captures that. Then when I commit that, it is done locally on my device until I push those changes to remote, right? The entire Git process is being handled locally on my machine. Then once it goes to remote, remote just saves those changes there. But a large percentage of the time, most changes or most times you're using Git, you'll be using it locally on your machine. Is that understandable?
Yes, it is.
If anyone is not clear, please ask a question. Okay, I think that has more. Okay, so Git is very fast. It can complete tasks in a while. Most of the Git operations are done on the local repository, like I explained, right? So it provides a huge speed because it's done locally. You're not waiting for a response from a remote server. When you're trying to commit a message, you wait for internet to push your code. No, you can work completely. You can work completely locally without having internet access until you want to commit your message to Git or push your changes to Git, right? So it can work. It works very fast in that sense. A centralized version control system continually communicates with a server somewhere. Now, when we say a centralized server version control system, now we are referring to that remote branch, right? Because it's centralized, everybody that is working on that project will have a connection to that project, to that remote repository. So that is where it's centralized. So if I, in Lagos here, I'm working with somebody in Ogbomoso on the same project, and then we still have a team member in San Francisco, in the United States, and then we have another team member in France, in Paris, in France, and all of us are working on the same repository, right? If the man in France makes a commit and then pushes his code to Git, right, and it lets me updates me, or I get a notification that he has pushed his code to Git, I in Lagos, in Ikorodu, or Yaba, or Ajegunle can do a Git fetch, a Git pull, and pull those changes that the man in France pushed, right? And I can get the code, the current version of our code down to my local device, right? So that is where centralized version control system is. Now, if the change the man in France pushed to Git, right? Because the man in France most likely will be working on his own branch, right? If we're working on the same branch or we're working on different branches, and every let's say the man in France has branch, like if you remember the initial explanation, I said the main branch is a long thread, right? A long thread of commits, right? So the man in France branches out, he names his branch man in France branch, and then he's adding commits and adding his changes and all of that. The man in Lagos branches out from the main and calls it Lagos branch. The man in Ogbomoso branches out from main and calls it Ogbomoso branch, right? And as we are all working, at every interval, somebody makes a pull request to main to have his changes merged to main. Now, we would have somebody that will be like a Git administrator who will review the code that's about to be merged and then merge those changes to the main. So that main now has all the changes that are, let's say, in the France branch merged into main. The man in Ogbomoso can pull the code that was the latest code in main, which now has all the changes, all the commits from France, and pull it down to Ogbomoso and continue working. Continue building what is building. Same for the man in Ikorodu, same for the man in Itamaga, in K2 or wherever, right? Is that clear? You guys get it? Get what I'm trying to say?
Yeah, I have
Yeah,
a question, please.
Yeah, please ask the question.
With the example you used, you said, okay, for example, if the man in France is yet to merge to the main branch, is it possible for me that is in Lagos to get his own part of
His
the
own branch.
repository? His own branch.
Yes,
Is
he
it
can.
possible?
He can pull his own branch as long as he has
Yeah.
pushed to the center. Yes, he can. He can also create a copy of his branch on the main repo. Yes. So if he has pushed, let's say, to merge a branch, right? You can either do that locally or you can do it remotely. Most cases, it's safer to do it. It's advisable to do it remotely in the remote branch. That's on GitHub itself or whichever version control system you're using, right? So for that merge to take place, the code and his branch must exist on that remote repository. Do you understand?
Okay. Okay.
Let me show you. Can you guys see my screen, right? Can you guys see my screen?
Yes, I can.
Yes.
Yes,
Okay,
we
let
can
me
see
show
us.
you what I mean. I think I should have a different branch. All right, so here we have 4 branches. There are different branches here. Let me give you. As you can see here, there are 4 branches for this repository, right? Then this is the main branch. This is the main branch. This is another branch. This is another branch, and this is another branch, right? Now, the main branch exists, and the changes in if I decide to go into this branch, I'll still see all the code for repository in that branch, but there will be changes, there will be differences, right? This is like a clone. So this one is saying it's one commit behind main, right? As you can see, that means the main branch is ahead of this branch by 1 commit, meaning this branch would have to be merged, or I can pull the changes that are in main into this branch for this branch to be up to date. This branch, this branch, which was the name of this branch? Alt service unit test is not up to date with the main. Do you understand? So now, let's assume the man in France is the one who owns this branch. Let's say this branch is named the man in France, right? And he adds his changes and pushes his branch. Once he pushes his code to Git with his branch, it will be sitting in this branch. Now the man in Ogbomosho can fetch all the changes that is in this branch. That is, I can make a request from this branch for the changes in this branch, and it will still come. Do you understand?
Yes, I do. Yes, I do.
So yes, so I can pull changes from this branch into another branch, as long as that branch is in the centralized version control system, which is this GitHub or this whichever version control system you are using. Once it is available on the remote, I can easily pull that change to my own branch and continue working from there, as long as it does not conflict, it doesn't create a merge conflict. That's I can easily merge those 2 changes, those 2 branches together. That's the code in the main branch or the code in the branch I'm pulling from with the branch I am working on. Once I can successfully merge the 2 code together without it breaking anything or having, let's say we have 2 lines of code that are now saying 2 different things. That is where you have conflict, right? If you know, if like take for example, let me just show you a brief example of what implementation conflict is. Now, this is saying that this is a change, right? Can you guys hear me?
Yeah.
Now, imagine that there are one extra line of code that is saying that this is not the correct change. There's another change that is supposed to be, right?
Okay.
This line 6. Line 6 is saying the new change is import bad request exception, not found exception from so. Let's say in one of the commits, one of the branches, there's another, this same line of code was altered to something else. Git might not know which one to take as the correct update. You understand now?
Yes.
So that is where a merge conflict is created. Now, Git will have to ask you, the developer, to pick which line of code it should take as the new change. Because Git is seeing 2 lines of code, 2 changes to a particular line of code, and it's not sure which one is the correct one. So it will not do it automatically. It will ask you to tell it which one it should accept as the correct change. and then accept that change, and then it will now register it as this is a new.
Sorry, sir.
update to
Is
that
it going to ask me that is the owner of a branch or the person who is in charge
Yes,
of
it
the
will
branch?
ask. It will ask you who is trying to merge it.
Okay.
Yes, sir, because you're the one that's about to merge both branches.
You can go carry and come back.
Who is that, please? Can you mute yourself? Right? Are we clear on that?
Yes, sir.
Yes, we are.
Okay, is anybody still confused at all about any of what we're talking about? It said must be branches be up to date with the main branch. Well, it depends. You can have that's if it's not up to date, that's why you'll be creating much conflict based on what I just explained. Right? If you have a branch that is so outdated, it doesn't have the latest commit, and you have your main branch so much ahead, right? If you're introducing that branch, you'd be introducing a code that is outdated. So you have to be careful merging such branches so that you don't introduce a code that you might not be needing again, or is outdated from the version or what you're trying to write your code for. Do you understand? Yeah, I'm not saying it's not possible to merge an outdated branch, but I'm just saying why would you want to do that if you have an outdated code on that branch? You understand? So you don't give yourself more work, and there's a very high probability of having merge conflicts or entirely breaking your code base. All right, so back to where we were. Yeah. All right. So we've talked about speed. Excuse me. So we've talked about speed. We're still on speed. So it provides a huge speed. Also, a centralized version control system continually communicates with a server somewhere, right? Performance tests conducted by Mozilla showed that it was extremely fast compared to VS Code's fetching version history from a local store repository. Okay, this is a single statement. Performance tests conducted by Mozilla showed that it was extremely fast compared to other VS Code's version control systems. Fetching version history from a locally stored repository is much faster than fetching it from a remote server. Of course, that's true. So you can't compare checking something locally than when you don't have to wait for internet to communicate with a remote with a source and then return a response. So it definitely will be faster in that regard. Right. So you can easily get your updated version control history locally than faster, not easily. You get it faster locally than you get from the remote. But at the same time, the most updated one can most likely be the remote because that is where everybody's commits will be going to when they are done, right? So the core part of Git is written in C, that's a programming language, which ignores runtime overheads associated with high-level languages. Okay. How many people here study computer science? Because this like the computer science related explanation. How many people here didn't study computer science? Or haven't done any computer related course?
I haven't studied computer science.
All right. Now I'll just okay. Let me just quickly explain a little concept of computer science. You can put your hands down, please. All right. Now programming languages, right, are generally programming languages are languages that you use to give computer instructions on how to perform a task, right? Now, high-level programming languages are languages that are written in human readable languages that can then be converted to binary. Like it's not, you have to convert high-level languages are languages, computer generally communicates in ones and zeros, right? It doesn't communicate English, computer doesn't know English. No matter the language, the computer, it does not understand A, B, C, D, no. What computers understand is 1 and 0. 1 and 0. So every line of code or every graphics or all the beautiful things you're seeing a computer can do, before it can perform that operation, it first converts all of those things to 1 and 0s, right? Now, there are high-level programming languages that are directly converted. They are written in human readable languages, because we cannot communicate in ones and zeros, of course. We can then use programming languages to communicate with computers, which will then be converted. Those commands we are writing and all of that will then be converted to one and zeros for the computer to translated to ones and zeros for the computer to run. Are you guys with me up to this point?
Yes.
Yes, sir. Yes, sir.
Yes,
But sorry, sir. How did computer get to understand 1 and 0?
Because that's what it understands. Ones and zeros, on and off, on and off. So that will be asking me to go deeper into how computers work. Just take it
No,
as
do it, sir.
computers work with 1 and 0, on and off. Those are the two things computer doesn't. It doesn't have a third option. On, it's either on, it's either off, it's either 1, or it's either 0. That is what computer. Now the series of ons and zeros is what computers can understand. 1 or 1, 1, 1, 1, or 0, 0, 0, whatever. Those combinations is what computers then understand. Right? Now we are bringing it back to programming languages now. Programming languages are languages that we can write in human readable language and then be converted to high level languages, computer programming languages that are written in human understandable language that is then converted to ones and zeros easily for the computer to understand, right? Now, then you now have other programming languages that are written in their own syntax and code, which will first be converted to a high level language before they're converted to one and zeros. Do you understand? Like what I'm saying is a code like programming language like JavaScript, I think is written in C# or C++ or something. I've forgotten. That JavaScript is not written directly in JavaScript. It's built on top of another programming language. Do you understand? So that programming language is built on another programming language. First has to be translated to the language it was built on, which would then be translated to the computer understandable language. So that process of conversion will create a bit of lag and takes a bit of time. But for a high level language like C, which is directly converted to computer understandable language, it will take less time and then would run faster. Right? Is that clear?
Yes, sir.
Okay. So when this is the core part of Git is written in C#, the core part of it is written in C#. That means that speed of it being written in a high level language is already there, which then ignores during runtime of converting a programming language to the high level programming language before they convert it. It doesn't have that overhead cost. Do you understand? Of a high level language rather. Right? It doesn't carry that overhead, it simply just converts and runs. So it becomes faster. That is where part of that speed that I'm trying to explain. Right? Is anybody still confused as to what we'll be talking about in regards to speed?
Not at all.
Okay. So far we've talked about speed in terms of Git running on your local device as part of one of his huge speed gains in speed, the programming language it is written in, and the ability to push your changes remotely and having everybody pull from there, right? Okay, so then then the final piece of speed is Git was developed to work with Linux kernel, therefore it's capable enough to handle large repositories effectively. From beginning, speed and performance has been Git's primary goal. So the the work environment for Git is Linux kernel, which allows it to perform. Oh, I'm sorry guys, I'm having a flu. I think that'll be going around for everybody, right? So we have branching and merging. I think I've already spoken about this, but we'll now expand more on it. So branching and merging are the great features of Git, which makes it different from other SCMs, right? SCM tools. Git allows creation of multiple branches without affecting each other. I think we've already talked about this.
Yes, we have. Yes, we have.
Is there anybody that's confused on this statement? Please?
Yes.
Not at all. Who is confused?
I want to
Huh?
know SC.
I can't really hear what you're saying.
I want to know
Is it
what
just me?
SCM. I want to know what SCM
SCM.
is. Yes.
Okay. Okay. Let's do it together. Source code management. Did you get that?
Okay. Yes. Yes, I understand.
All right. You need more explanation. Hello.
No. No. Thank you.
Right. Okay. So, but at this point, anybody is confused on what this statement is saying? Git allows creation of multiple branches without affecting each other. Okay. So we can perform tasks like creation, deletion, merging on branches. Now we can create a branch, we can merge a branch, we can delete a branch. You didn't say anything like update a branch. We can't update a branch. No. We can, sorry. We can perform tasks like create, delete, and merge. And yes, we can update a branch. Sorry, we can update a branch. My mind was thinking of commit on branches. And these tasks take a few seconds only. We know are some of the features that can be achieved by branching. We can create a separate branch. We can even create a branch off of another branch. You guys know that that's possible. You can create a branch, a main branch out of it and create the Paris branch, and see branch out of the Paris branch to have another branch, which you can then merge into the Paris branch and then still merge the Paris branch into the main branch. Right? And it's still possible to merge that offshoot branch into the main branch, as long as there is no commit of no merge conflict. It's possible to merge it. Right? We can create a separate branch off of a new module of the project, commit and delete it whenever we want. So after we must have, it's not that it's a must. After you most likely have committed the changes to the branch that you created. After you've committed to the main branch, you can delete the branch that you created. Right? You can delete it in order to maybe reuse the name or use it or just to clear the history. Right? We can have a production branch, which always has what goes into production and can be made for testing in the test branch. So if you guys remember, when I started, I was telling you, I mentioned that you have a main branch, right? And that branch, you don't want to work on that branch, right? You always want to create a branch off the main branch, add whatever features you want to add, and then merge it to the main branch. Now, the reason for this most times is that you do not want to introduce a bug to a working code. Now, if you're working on the main branch and you are adding changes and adding changes without creating another branch, you won't know. It will not be easy. Not that it's impossible. It's not going to be easy for you to track when you introduce a bug into the code. But when you're working on another branch, all the code that is in that main will still be in that branch that you've created. You can add your changes, you can introduce your new code, you can do whatever you want. And when you are confident that this branch and the code that is in this branch works perfectly and is okay, you can then have that branch merged to the main branch. Now, you can also have a branch called a development branch. That branch is where you add code to that you're still testing. Let's say you've written the code, everybody has written their code, and you're building an application, and it's when they say an application is in development, is everyone is writing code and we're pushing the code to that branch and we are testing it. We are running random tests just to test it. We are introducing new changes. Even if it breaks, nothing is going to happen, right? That is the main, that's the development branch. But you see production branch. That branch is the branch where your application, the live server, the live code is running on that branch. Now that branch, that production branch, you do not introduce changes that you have not tested, that you're not confident will not break production code. Are you guys with me up to this point? Hello?
Yes, to a
Are you
good
guys hear me?
extent.
Okay, cool. So now in production branch, that is where before somebody even merges, creates a PR, a pull request to merge their code to that branch, it needs to go through different levels of testing and different. Somebody has to review the code that is about to be merged, so as not to introduce a bug to production code, right? Because that is where you, if your code or your production server or code breaks, the process of troubleshooting it, you would be losing money in the business, right? So in order to avoid that, you always want to have a development branch that will carry your code and you can run all the tests that you want to run. You can, it's just like having a punching bag. You can use the development branch as your punching bag. You can beat up the branch, do whatever rubbish you want to do there, and ensure that the code you want to now merge from development to production is solid and ready for business and will not break in production. You guys get it now? Does anybody have any question, please? I think we've used most of our time for this morning session, but let me just, I'm trying to just round up, but I think I may not be able to do that. So let me just complete this branching and measuring, and then we can call it a morning and continue the rest in the afternoon. Right. So we can have a production branch which always has what goes into production and can be merged for testing in the test branch. We can create a demo branch for experiment and check if it is working. We can also remove it if needed. The core benefit of branching is if we want to push something to a remote repository, we do not have to push all our branches. We can only select a few of our branches or all of them together. Meaning, if your mail is in the remote and you're working locally, you have created a clone of the repository on your local machine, right? The repository you cloned is still in the remote, right? Your local repository, you can create multiple branches there. All of those branches you've created, none of them exist on the remote until you push that branch to remote, right? So you can be experimenting with yourself locally, you can experimenting with your code and whatever, with different branches just to get the right fix for whatever code you're writing, right? And then when you're done, the branch that has the fix or the code that you want to now push, you now push that. If you like, you can even push all of them and have somebody look at all the branches you created. One of your colleagues can look at all the branches you created and review or pick something from them. So that's the power of one of Git's great features, branching and merging. So does anybody have any question in regards to branching and merging, please? Hello?
No question, sir.
Jay Francis, your hand is up. Go for it. Jay Francis, can you ask a question, please?
Hello.
Hi.
Yeah, I have
Hello.
a question.
Go for it, sir.
Okay, my name is Additional, Oladeji Additional.
Yeah, hi, Shino.
Yeah. So yesterday we were given assignment by Omolola. So while
Yes.
carrying out the assignment, I encountered some errors. It was showing error 403 that remote permission to Iro Omolola's that's I am GitHub handle denied to Additional. I was trying to push my work to our own space, kind of.
Why will you do that? Why will you try
She said
to
we
push
should
your
clone.
code?
She said we should clone a repository. So
Yes.
after cloning the repository, then we should
Yes.
create a branch with our surname.
Yes. Yes.
So after doing that, we should create a file that will
Yes.
contain about ourselves. So after doing that, I was not trying to push. Then it was giving me that error.
Where are you pushing it to?
I was trying to push it to my own repository, my own
No.
Git. So it was not showing me error.
You don't, do you have do you have that repo in your own GitHub?
Yes, I do.
You don't have it.
I do.
What you have is you have a copy of it. What you wanted to do is I'm guessing the repo she gave you to clone is a public repo, right? So when you
Yes.
created a clone of it, right, you had a copy of it. You can you have a copy, not that you have the exact access to her repo, right? What that means is, did you fork the repo?
I did not fork. I only cloned it. I didn't fork it.
So okay, so you cloned it, right? So that means
Yes.
you only cloned her repo. The only thing you can do is you can create, if you don't have access to it, you can create a branch, right? The branch you created. You can now push. What you should have done is you should have forked the repo first. After forking that repo, you then create a branch. After you've forked, then clone, then create a branch. Then when you create a branch, you now push the branch, not to the main. You will now do a git push origin, the name of the branch you created back. Then when you have done that, you can then go on the repository and then create a pull request. So that that branch you created can then be merged. Do you understand the flow now?
Yes. All right.
Okay,
Then I
can
think
you ask
my
a question?
question would be, although it's not for this class, but like,
Hold on,
since
can
said
you
the-
hold on? Can you hold on? Can you hold on? J. Francis, can you ask a question, please?
Thank you very much. Sorry, I needed to walk out from the office place, from my workspace, so that I could speak. That was why it took a while. Okay. Please, my question is on the pull request. When you have when you've been able to push to your branch, like when you're pushing to your branch, you need to create a new branch on your own. So you do not make mistakes from pushing to the main branch, right?
Yes, yes.
So when you are done, you now merge. When I say merge, the pull request, is it like does pull request do the same thing as merge?
Yes, that's the merge. That's how you merge. You create a pull request. You don't just
Okay,
merge.
when you create a pull request, that's the same thing as merging.
Yes.
I know in the assignment, I think I kind of had issues with the pull request, but I'm going to retry it today, and hopefully it should go through.
All right.
So I was able to push. Everything. I was able to push. I was able to do everything. I think it was remaining for me to pull request. That was going to remain. Thank you for the clarification.
Yeah, sure. You're welcome. All right. Who was speaking just then? Can you ask the question?
Okay. My question was, you said you need to fork the repo first.
Yeah.
So how do you go about that?
On GitHub, right?
Yes.
This is how you fork repo. Can you see my screen?
Yeah.
So when you open the repository you want to fork, you just come here and click fork.
Okay, does that mean I need to enter a link on GitHub on the web?
You have to find where that repository is, right? Because you actually have to go to the repository and then fork it. What that creates is a copy of that repository on your own GitHub. Do you understand? If not, you just be copying code. And if you make changes, you do not have permission to push the code back. Do you understand?
Yes, I understand. So that means why after cloning on the bash script, then I have to come to the web GitHub.
Come again.
So that means after cloning the repo via bash, then I will come back.
You have to fork it first. You have to come here, fork it, then clone. Let me see if I can get let me see. Okay, this is not my repo. So if I fork this now, right? I'm about to create a new version of that repo. This is the file name. I'm going to copy that person's repository into my own GitHub account. Do you understand?
Yes.
Then that gives me administrative rights to that repo. It's just like having a copy that I can now edit and do whatever I want to do. another, if you don't do this, the only other way to maybe make changes to that repository will be to clone it and then physically alter the code on your machine. Like physically alter the code when you have cloned it, you have copied it, right? But then to push and do all those things, you can't do that. You have to then go on your own repository, your GitHub account, create a repository from start, and then make that code you copied a new repository. Do you understand?
Okay.
So forking it
So that means I have to
does
use
that. Forking it does it for you. So it creates that copy and then gives you a repository to clone that you have access to. So I suggest you guys use between an afternoon to do some more research on what forking is.
Okay. Thank you.
All right, Steven, can you ask a question, please?
Yeah, it was Steven that just asked.
Okay, your hand is up. That's right. It's up. Okay, John. This is going to be the last question for today. Because we are way beyond us. Okay. So, John,
Okay, sir.
John,
thank you, sir. So, you're saying that once we
just call
fork,
me James, I beg.
okay. Okay, so you're saying once we fork the repo and we already have it on our GitHub, we cannot do what clone, then we can do whatever it is we want to do and push.
Yes.
Okay. Thank you very much.
You're welcome. All right, so we'll be aligning in the afternoon and we'll practice some of the things we talked about. We'll create a new repository, we'll push code to that repository, we'll create different branches, we'll merge, we'll do a PR, we'll merge, and we'll see how it works. All right, guys, see you in the afternoon.